There it goes. Alrighty, guys. We're back.
We're back.
Yelling at the dogs and trying to keep everybody quiet. We can do this. And back in section 2. So section 2 has some kind of deep concepts in it that require some practice. And you're just going to have to get used. Really, this is, well, maybe not the main, but the main place is by writing in geometry with the concepts that we're talking about.
Right.
You do have to write out English statements in a lot of doing here. So again, you just have to have some patience with that, and it's a little bit of work, but you have to hang in there and stay with that. So we're talking about conditional statements in this section, and kind of based on our conjectures and so on that we were talking about last section, but we're talking about a conditional statement and used in science. Conditional statements are statements that have a hypothesis and a conclusion. Think about that. Hopefully you've heard about that within your basic science classes, that you have a hypothesis conclusion to any experiment. And so we have the same thing here, specifically in geometry. And we talk a little bit about that in Algebra 1 even, don't we?
Right. Yeah. A little bit here and there. I mean, it's...
Yeah, it's not one of the main concepts. But and so our hypothesis and hypothesis, okay? So anytime you see an if inside of the statement, that whatever comes after the if, it does not include the if is not part of the hypothesis. But whatever comes after the if, that's the hypothesis. And then there is a then, so we're talking about an if-then statement. If such and such is true, then this has to be true also. And so the then part, again, not including the word then, but after the word then, is the conclusion that we can come up with. Okay, so we have hypothesis and conclusion all built inside of an if-then statement. All right, called a conditional statement.
Now, Mr. Scritchfield, do these ones kind of move away from this, or are we getting more analytical?
There's some inductive side of things, and again, building our steps of logic to get to deductive reasoning here. So, okay, term here, another vocabulary term here called the, and it looks like negative. What it is, the negation of a statement is the, and so the negation of a statement always has a not in it, the word not, N-O-T. All right, that's typically how you can change a statement to a negation, is by putting the word not in it, or don't, or something along that line, negative to it. Okay.
All right, so when we talk about this stuff here, the thing I want you guys to always remember, if-thens, is that really, guys, a lot of this, what we're doing right now, is just to kind of get you used to some of the vocabulary that's with it. But really, until we do a lot of examples on this, it might be a little bit of a challenge. And so one of the parts of the if-then is what we call a converse. And basically, a converse is so if my if-then is like this, the converse is we switch the hypothesis and conclusion. So the conclusion goes to the front, and the hypothesis goes to the back, excuse me. And that's what we can consider a converse. And when we look at an example, it'll kind of make some sense here.
It will, but I think this relates to what you've already said several times, of the whole visual math thing. Think about it right now for just the visual, just what Mr. Bedell said. You're just physically switching those two statements, just visually switching that. The math side or the geometry side of that will make sense when we look at it in a little different way. But just think about that switch going on visually.
Yep.
Okay?
If I was to give you an example here, guys, and this isn't necessarily, we'll talk about this, but the converse would be like, let's say I made the conditional statement of, if it rains, then I get wet. And so that's my if-then. If it rains, then I get wet. And if I switch those, it says, if I get wet, then it rained. And you know, and is that necessarily true? Well, that's debatable.
Right.
And so you could have a counterexample to that of, you know, you could take a shower, you know, or something like that. But that's the idea of, if it rains, then I get wet, but then the converse just switches it to, if I got wet, then it rained.
Right.
You know, and so the next one is called the inverse. And here's that word negate that Mr. Scritchfield talked on the previous slide, where it's kind of the idea of not. So an inverse negates both the original hypothesis and the conclusion. So it's kind of like the idea again, if it rains, then I get wet. If it didn't rain, then I didn't get wet. If it doesn't rain, I don't get wet. Now, once again, that's debatable.
Whether that's true or not.
Exactly. Whether it's true or not is debatable, but you kind of get the idea. So what I say with my hands, so this is if-then. This is the converse, like this. You switch your hands. So if-then, converse. And then the inverse is my hands stay the way they are, and then I just switch my hands. That's kind of a way Mr. Weiss and I used to kind of try to explain it, using the hands, kind of that visual idea.
Yeah, because they stay in the same order.
Right.
On the inverse, you just put knots in front of them.
Exactly. You negate them. So you make them into their opposites.
Yeah.
Okay, and then we have, I like this word, it just sounds cool to me, the contrapositive. So, you know, this is the idea of two wrongs make a right to me.
Yeah.
So contrapositive is writing the negation of the converse. So if this is the if-then, okay, the contrapositive is a combination of converse and inverse. So if this is my normal if-then, I inverse it and I switch them, and that's the contrapositive. So if-then, okay, and then to go from if-then to contrapositive, I negate them and switch them, and that's what it is. So if we talk about that, if it rains then I get wet, we just switch that. If I didn't get wet, then it didn't rain, which is true, because you couldn't have got it wet if you didn't rain. And so it's kind of the two wrongs make a right kind of a thing. It's really kind of cool. I love that word contrapositive. It just sounds cool.
So we're going to be using that.
Yep.
And keep that straight from counterexample.
Right.
Don't mix those two.
Right.
Okay. So let's look at some examples. So here's and this you're gonna have some homework like this or some assignments like this. Okay. And so they give you a statement, but it's not an if-then form, and they want you to change it to if-then form. And so our original statement in green up there is a right angle is 90 degrees, or maybe better if it said a right angle measures 90 degrees. And so if we want to convert that to an if-then statement to begin with, and it does need to be if-then before we go to the others, then we can put that in if-then statement as if an angle is a right angle, then it measures 90 degrees. So we got to know what we're talking about in the first place. We can't just say if something's right or if it's right or whatever. We got to know what we're talking about. We got to put angle in there. So if an angle is a right angle, then it measures 90 degrees. Okay? So we want the converse of it. What does the converse do? Switches the if and the then. If an angle measures 90 degrees, so we take the second part of that statement, but notice the if an angle. We still got to know what we're talking about. We can't say if it measures 90 degrees, if what measures 90 degrees. We got to know what we're talking about. So if an angle measures 90 degrees, then it is a right angle. Okay, now this one happens to be true that way.
Yep.
Okay, depends on what we're talking about for them to be true all the time or not. Okay, for the inverse, remember, we're going to negate each one of them. So we go back to the original if-then, keep it in that order, but put knots in front of them. So if an angle is not a right angle, then it does not measure 90 degrees.
Which is also true.
Which is also true in this case. Okay, Mr. Bedella's favorite, the contrapositive, we're going to go back to the original
it's like
statement.
doing the Macarena.
There you go. We can get up and dance right now. Go back to the original statement, negate both of them, and switch them. So if an angle does not measure 90 degrees, there's the second half of the original statement with a knot in it, then it is not a right angle. And once again, that's true.
Yep.
Okay? So we picked an example here where they all happen to be true.
Which is
not always
important.
the case. It is important.
Yeah, and when they are all true, guys, it's important because it makes a specific thing happen in geometry.
Right.
Or really with anything, I guess,
Yeah.
in order to be a definition. We'll talk
Right.
about that here
Right.
in a moment.
Okay?
So
we're going to do several examples like this. And yes, I understand it means writing out these sentences each time and so on, guys, but we got to work through that. All right?
all right, so a biconditional statement. This kind of
is where it
goes.
gets to.
Yeah. So in order to be a biconditional statement, it says are statements that contain the phrase if and only if, and are made when the original and the converse are true. And so if you can get this and this, okay, to be true, then we have what's called a biconditional statement, and we say, like if you go back to that one about a right angle is 90 degrees, and you can kind of say a right angle is a right angle if and only if its measure is 90 degrees. Because if you think about a right angle, guys, what's the only way it's a right angle? If it's 90 degrees. And if you switch that, okay, an angle that's 90 degrees is a right angle if and only if it's 90 degrees. So, I mean, it's just,
These
kind
go
of
along
makes
with
sense.
definitions.
Yeah.
And if and only if is usually a definition of
Right.
something.
Right.
And I think that's the example here, isn't it?
Yeah, there we go.
There we go.
So a right angle is a right angle if and only if it measures 90 degrees. And then if we switch that, maybe not.
So that's the if and only if.
Yeah,
so
that's
they've already
the
put it together.
My bad.
So an angle is a right angle if and only if. That's the critical part of this that makes it a biconditional. Notice there's no if at the beginning.
Right.
An angle is a right angle if and only if it measures 90 degrees.
I mean, and like I said, if you think about that, that makes sense. I mean, you hear 90, you think right angle. I mean, that's just the way I do it.
And we sometimes abbreviate the if and only if. You'll see an if with two F's on it. That means if and only if. It's not a typo or whatever, but an if with two F's on it means if and only if. Okay? And then we're up to our last slide, which this one really doesn't have anything to do with the rest of the section, but we're defining what perpendicular lines are.
I guess they could practice. You know what? For homework, I got an idea.
Practice
Yeah,
this,
for homework, you could come in with the four conditional statements off this.
for this statement.
Yeah,
Yeah, yeah. But we've already talked about this when we did our constructions.
yeah, we did.
Our football construction, as I call it, to where we do the perpendicular bisector in the middle. So we already know what perpendicular is.
Right.
Two lines are perpendicular if they intersect to form a right angle. So if they intersect to form a 90-degree angle. And notice the little notation here. So we have segment or line, we could say line or segment here. Line or segment AD is perpendicular to, so it's almost like a little picture of what's going on. You see that it forms a right angle there. Is perpendicular to line or segment BC. So the way that's written right there, it's segment AD is perpendicular to segment BC. And we have a diagram to show that. Okay, so what do you want to do for putting the four statements down for that?
I'd like to see you guys come in tomorrow with an if-then. Okay, so go back to that slide if you need to on the video, and so come up with the if-then statement. Okay, so come up with this statement
for this definition.
For this
right here.
definition, then come up with the converse. Okay, then come up with the inverse, and then come up with the contrapositive. And that'd be kind of cool if you guys could, just try it, see how you do. And we're going to do a lot of those
That's what we're gonna be
examples in
doing
class.
so
Yeah,
you need to get used to it right away here.
yeah.
So,
Okay.
so we'll see you in class to do that.
All right.
Okay.